Thanks for the introduction. So, yeah, as being said, today we're going to talk about the GitOps for MLOps, and we're going to talk about Kubernetes. And it's really exciting to see how many people are coming to listen about Kubernetes 9 a.m. Saturday. Good for the industry. So, yeah, as being said, I'm Gleb. I'm originally from Russia. I'm a Bachelor of Science in Nuclear Physics. I have 6 years, it's 7 now actually, of like MLE, data science related fields. I'm currently working as a senior machine learning engineer at Bumble, and I wish to become chess grandmaster one day. And first, we're going to talk about what MLOps is in general, and that's how the regular data science workflow looks like. We're not going to go through it right now. We're going to first see how the regular data scientist or machine learning scientist sees that. It's more like that. It's like, but that's the desired way you want it to be. You don't want a data scientist to think about all the rest that your platform providing. So you want them only to be focused on building the models using the Jupyter, and the rest should be accommodated by the MLOps team. But in general, how this looks like. We have ML scientists and data scientists working in a company building models, and we have the workspace for them, and that's something that is different for the data scientist and a regular software developer and engineer, because software developer engineer can build and can write code in their own laptop, let's say in their own environment, but for a data scientist, you need to provide a workspace with servers, with the RAM or with number of CPUs, with GPUs, so they can use them to load large data sets, let's say, because you cannot load like 400 gigabytes inside your Mac memory, right? It's not going to work. So that's why that's a difference between the ML scientists in general, between data scientists and regular software engineers. So using this workspace, data scientists are usually connected to the data infrastructure, so they can read features and read data easily. And using that, they're providing models. They're exporting models that needs to be deployed into production later. So, and these models, using some CI/CD tools, are going to production platform, which is, again, something that MLOps is building. And those production platform is used to send, like, to receive requests from the actual clients who are using these models. And also, there could be implemented a feedback loop, which pretty much sends the feedback from the production back to the workspace so the data scientist can analyze it and probably train a better version of the model. Where do you think MLOps sits here? The right answer is everywhere, right? That's the MLOps guy. So talking about the MLOps, like MLOps is the one making sure the connection between the data infrastructure and the workspace is clear, fast, and reliable. They don't want data scientists to think about it. As like going back to the slide, pd.read SQL should be enough for either data scientist or machine learning scientist or something similar, right, when it comes not to SQL. So MLOps is the one making the workspace, creating the workspace platform, making sure the resources are available for data scientists to use. MLOps is the one making sure the export of the models is working properly, because MLOps is the guy building the production platform, and they know what kind of models they are able to serve and in which format. So that's why they're helping exporting these models for data scientists. They are helping data scientists to export these models. And MLOps is the guy making the CI/CD process, because, again, they know how to deploy stuff to their production model. So they are the ones building this. They are taking care of the production platform, sometimes accompanied by IT ops engineers of the company, like service engineers, but still, MLOps is here as well. And sometimes also MLOps is making sure the requests that are sent to production platform are in the right format. Because, again, you know what kind of models do you serve, you know what protocols do you use, so you're the one making sure those requests are going smoothly. And again, going back to the data scientist, that's the desired way. The things that we just discussed is not something that a data scientist should think about. I was working as a data scientist back in the days, so I know how hard it is to build a model. You should be fully dedicated doing your modeling job instead of thinking about how this model should be exported or deployed or whatsoever. So you, as an MLOps, you are the one empowering the data science team and making sure data scientists and machine learning scientists are comfortable enough to provide the best model they can. And from here, we're going to talk a little bit about MLOps at Bumble and how this process looks like in our company. So for those who don't know, Bumble is the company operating dating apps. We have 3 large dating apps right now, which are Badoo, Bumble, and Fruits. And we have more than 500 million users worldwide. And of course, we are doing a lot of machine learning here. So there is a team of around 25 data scientists and machine learning engineers that are training models and making sure they're going to production. And in terms of models, what we do is we are mostly focused on 2 areas, on three, let's say. The first one is the user experience, which includes our recommender engine. The second one is the integrity and safety, which includes such things like private detector or toxicity detector. So we're making sure our users are safe at a platform. And there is also a stream called business optimizations, where we are focused to make sure that, for example, year 1 value of the client, like we know it. We are able to forecast it. So, and these models that we are making at Bumble are empowered by the internal MLOps platform that we've built. Could be very scary. So, I mean, like, don't really focus on, like, for those who are really interested, yeah, they can take a picture and take a look later, but the main thing that I wanted to say here is that our MLOps platform is built on top of open source software, mostly. And that's what we're doing. We are making use of Kubernetes. And on top of Kubernetes, we are, oops, pardon. So yeah, on top of Kubernetes, we are deploying the software that is being developed and maintained by open source community. And we think that's the most effective way to do so, because we are not spending time, like, of course we are developing our own applications still, but for something that is already developed by community, we are making use of it. And as you can see here, pretty much, there is like ClearML, Milvus. I don't know if from the previous presentation it was mentioned or not. That's like one of the most popular vector database, let's say. So, and like, yeah, Prometheus we're using for monitoring Grafana, for visualizations, Argo CD for GitOps, this kind of stuff. So, and that's where our GitOps paradigm grow from in general. Again, we are making use of the open source software mostly at Bumble. And we are making sure it works properly. And we are able to adapt this open source software for our Bumble needs. So, and in order to do so, we are making use of GitOps. And GitOps is actually a paradigm that modernizes software development by making sure that the application's code is being served in a single source of truth. Probably many of you have already heard of Terraform. Terraform is like a paradigm where you maintain your infrastructure, like infrastructure as a code, right? Where you have the code of your infrastructure, of your cloud infrastructure stored somewhere. We're making use of Terraform as well. We are operating in a hybrid setting. We have some bare metal machines. We also have some cloud machines. For those cloud machines, we do make use of Terraform. But GitOps is similar to Terraform in this case. And like the paradigm is similar, let's say. Terraform is making use of infrastructure as a code. But GitOps is more like your application state as a code. So you have a single source of truth where your application is stored, which is a Git repository. And yeah, as I was saying, it's quite similar to Terraform. So in general, that's the sample of YAML that you are deploying to Kubernetes. For those who don't know, Kubernetes is the container orchestration platform. I guess everybody knows what Docker is. So it's like the layer on top of Docker to make sure we can not just deploy containers, but also orchestrate them, like scale, make sure the load balancer is working here. So yeah, this kind of stuff. And again, you have, let's say, you have resources that you would like to deploy to your Kubernetes. And those are the YAML files from the very beginning. And what you do, like what GitOps is about, is that you are storing those YAML files in Git. And then you are making use of the GitOps tools. The most popular ones are Argo and Flux. And Argo and Flux are the tools that are helping you to deploy stuff directly from the Git to your Kubernetes. And that's a good thing about it. That's a good thing about it. It is a very convenient way to manage the resources that are deployed to your cluster. And also, in order to make use of the GitOps properly and fully, there are such tools as Customize and Helm that helps you combining the manifests. Because, for example, you have a base manifest that is shipped by the community like that. And you want to adapt it to your environments. And you don't want to rewrite this manifest completely. You don't want to make changes to the base manifest. Because next time you're upgrading this base manifest, you have no idea like what's being changed previously, right? Either you have to compare with the previous version, which is not so convenient, or you have to make use of overlays and the capabilities that Customize and Helm is providing. So again, the initial manifest is taken from Git or Helm. Like, we're not going to stop on Helm that much. You can consider Helm pretty much as a Git, but where the manifests are stored, actually. So then you're making use of Customize, where you're combining these YAMLs. You're making sure that these YAMLs are suitable for your specific environment. And then you're making use of either Argo, CD, or Flux again to deploy your stuff to the different zones or different clusters that you have. And here at Bumble, we have come to the specific structure of the GitOps repository that we're using. We're calling it two-level overlay structure. And it has some benefits, and we're going to talk through that. But in general, in order to have smooth GitOps experience before structuring your repository, you should be thinking of a couple of points. First one is make sure the proposed repository structure is clear and transparent. It is hard to navigate over the messy repository structure, right? It's just like the obvious thing. So the second one is make sure you can promote changes between environments easily, and also you're not introducing any security risk while doing that. For example, imagine you have the situation where you're committing something to dev, and it can change something in prod. It's not a good thing. And also, you don't want to store the secrets from the prod in the dev environment, right? Like, you're exposing the secrets from prod in the dev. That's an anti-pattern. So you should think that your repository structure is not allowing it by design. Consider having a single source of truth for all dependencies. Like, single source of truth for your cluster is still going to be Git. But also, we should be avoiding duplicated code. Because imagine you have some resource that you need to change in your 15 different environments. You don't want to go and edit 15 different files, right? Doesn't make sense. So it's easier to like change just one, and then everything is rolled out to all the environments. That's a nice thing. That's something that should be taken into account by design as well. Evaluate the ease of bringing up new environments. For example, you have 15 zones. I love this meme, by the way. Imagine you have like 15 zones, and you want to add 5 more. When we're talking about zones in general, like, well, when I'm saying zone, I'm saying that, for example, you have a cluster in Amsterdam, and you have a cluster in New York, and you're doing good in Europe and North America, but you forgot about like Southeast Asia, let's say. You want to have another cluster in Singapore. So that's what I'm calling a zone, right? Make sure those kind of zones and new environments could be brought up easily to your cluster, to your platform. And that's also a thing that the nice GitOps structure brings. I wasn't able to make a meme for this one, sorry. So, and yeah, also consider possible privilege separation issues. For example, you want your data scientist to be able to commit stuff to dev directly without your involvement. And you don't want the data scientist to break prod, right? So they shouldn't be able to commit stuff, to change anything in prod while they are deploying something to dev. And taking into account all the things mentioned, we are proposing the two-level overlay structure at Bumble. Here is an example. We have a private detector developed within the company. Now it's open source. And we are considering that private detector is, in general, the open source model that we are making use of. Like, we are adapting a piece of open source software for our needs. And we have 2 folders in the repository. The first one is base, which contains base resources, and the second one is overlays, which contains zone-specific changes. But in a base folder, for each application, we also have another base folder. And here, for example, private detector is only shipped as a single manifest, which is deployment.yaml. Here is an example of it. Here is the deployment.yaml. And we have cluster agnostic, but Bumble specific changes. So the way we adapt, like the changes that we want to apply to all the zones and all the clusters we have, but that are not shipped like that by the community. So we want to still apply some changes to the manifest that is being shipped from the community. And that's what we're doing. Here's an example. We have the deployment, a single deployment with like 3 replicas of the private detector container. Let's say the private detector version is 1.14.2. And first, we are trying to make the Bumble-related change, but cluster agnostic again. So what we're doing is we're applying a patch, and we're saying that this deployment, instead of label app PD, should be having the label app Bumble PDD. So, and this change is being applied to all the zones where we are going to have private detector then. And that's because how the customization looks like. We're taking the resource from the base, we're taking the deployment resource from the base, and we're applying this patch. What happens next? Here is the zone 1 patch that we have. Again, since that's the private detector, we are assuming that it could be optimized for a certain task. And here we are optimizing it for the aubergine. And we are saying that in zone 1, our data scientist tested that we should be optimizing the private detector for the aubergine in zone 1 because it works better like that. And we want to apply this change. And we are saying that we are adding this environment variable, and we are making another patch. And also, the changes about the number of replicas as well. We are saying that for zone 1, we can handle all the load that is going to go to private detector with only 5 replicas, only 5 running instances with a load balancer on top of it. And that's how the customization here looks like. We are not going to the very base deployment. We are instead going to the one that is mentioned previously already. This is actually a typo. There should be a private detector. Sorry about that. So yeah, we're going to the overlay. So we are like taking care, we're making use of the overlay that we've created already. And then we're applying a zone 1 patch for this overlay. And we also have a zone 2. This zone 1, let's say, is again Amsterdam. And we have the zone 2, which is New York. And in New York, we realized that only a single replica of the private detector can handle all the load. So we don't want to spin up more. And we just saying that the number of replicas should be 1. And also our data scientists tested that the private detector should be optimized for the peach instead of the aubergine. So, and we are passing this variable as well, because private detector is accepting this variable, what it should be optimized for. And again, we are making use of, no, Istio, unfortunately, private detector. So yeah, we're making use of the Bumble overlay that we've created previously. So that's why it's a 2-level overlays that we are suggesting. The first one is, again, company-specific, which is Bumble-specific, but cluster-agnostic. And the second one, second layer, is the zone-specific changes. And that's what we end up with. We have started from the manifest like that, which is shipped like that from the community. And we are changing for the zone 1, we are changing the label. And for the zone 2, we are also changing the label. So those are the cluster-agnostic changes. But also, as cluster-specific changes, we are changing the number of replicas. And we are changing what private detector is optimized for. Why did we came to this kind of structure? Again, going to the beginning, we are adapting a lot of open source software in our MLOps platform. And we need to make sure we can make changes and adapt it to our needs. But also, we need to make sure that those changes are transparent, and it should be easy to use and change and promote new environments and everything that I mentioned before. So, and we are going to go through this structure and check how the things that we discussed apply to it. For example, the first thing that this two-level overlays structure brings is transparency. What you start with is that you have that each cluster is having a number of resources they should be running. And it's quite easy to see. For example, in zone 1, we are running private detector and toxicity detector because we need them. For zone 2, we don't need toxicity detector. So we're just saying that there shouldn't be a toxicity detector. Still, your toxicity detector resource is going to be in base. If it's the one shipped from the community, then you're going to have Bumble overlay inside your toxicity detector folder. But the big thing is that it is very transparent which cluster should run what. The next thing is extensibility. The process of adding a new resource is very transparent. For example, you have private detector, toxicity detector, and scam detector as well. So, and yeah, scam detector is just being added recently. And you want to add scam detector to the zone 1. What you're doing, you're creating a base folder for the scam detector, and you're creating possibly your company's overlay inside. And then you're saying that it should be running in zone 1. Again, everything is super transparent, and the process of adding in new resources is very convenient and easy. Scalability. It's very obvious that, for example, you had zone 1 and zone 2, but also you want to add a zone 3. So what you're doing is possibly you're copy-pasting your zone 1 or zone 2 environment or whatsoever, making sure that the overlay changes that you made for your zone are changed accordingly to add zone 3. And then you're just deploying it. Very smooth. Convenience. So resource upgrades, and that's the thing that I like the most, because I'm a very lazy engineer. Resource upgrades require a single commit to be rolled out to all overlay clusters. For example, imagine you have the private detector version 1.14.2, and you want to upgrade it to 1.15.1 that was just released by the community. What you're doing, instead of going to each zone and applying the changes manually, you are just changing the base manifest that is being shipped by the community, or the base number of manifests that are shipped by the community. And then you're applying all these changes to all your clusters automatically. For example, you have like not 2 zones, but 25. This is very convenient. And also, one of my favorite things is collaboration, because this kind of structure is a little bit complicated in general, but it brings collaboration. It helps collaboration in the team. Because, for example, imagine you are enjoying the sunset somewhere at Sri Lanka, I don't know. You're on holiday, and your team wants to upgrade some resource. And they're not going to be calling you and saying like, hey, Gleb, we need your help to upgrade stuff. They already see what kind of changes you made to the base manifest. The base manifest stays the same all the time. You're not changing it. You're just applying overlays on top of it. The first overlay is the company-level overlay. The second one is the zone-related overlay. And it's very transparent, and your colleague can pretty much see what kind of changes have you made already. So, and this helps collaboration a lot. And also, the last one, not the least, is the security. We are making use of 3 different repositories. We have 3 different environments, which are dev, staging, and prod. And repo-level access control improves security over branch-based setup. Actually, there are a lot of articles that are like you can find easily in the internet that saying that branch-based setup for Kubernetes is an anti-pattern. I'm not going to go deep into it, but I also agree with that. And that's what we're doing. We're having a separate repository because, again, we are allowing data scientists to deploy stuff directly to dev, right? And we want to make sure that once they're deploying something to dev, they're not breaking anything in prod. That's why we have 3 different repositories. But also inside the repositories, we are having the same structure that we just discussed, right? Where we have like the base folder with the manifest shipped from the community and the Bumble-related overlay. And we have the zone overlays, which has like zone-specific setups. And that's it. Thank you.
Great. Thanks, Gleb. That was a really great talk. Time for some questions. Who'd like to start?
Thank you. Thank you. If you didn't have any of that structure, like you were coming to that company, none of that DevOps structure at all, where would you start, and how would you build it?
That's an extensive one. Fortunately, I had a consultancy background, as being mentioned. So, yeah, I mean, in general, if the platform that you are deciding to go with is Kubernetes-based, then, like, the first thing is deciding which platform you're going with, right? If it's Kubernetes-based, then it would just require this kind of structure. If you already have a Kubernetes where you want to apply the structure, for example, your Kubernetes currently is just its manifest from the command line, right? And so as far as I know, there are some tools that are going to help you with that, that can create the GitOps repository out of the running Kubernetes cluster. They can just fetch the manifest from it and create a repository, if that answers your question. Thank you.
Hi, great talk, thank you. So two mixed questions. First, do the data scientists also contribute with the changes in the YAMLs and resources that you deploy in the Kubernetes structure? And second, like for the ones that manage the structure, how do you apply testing and how do you verify that your changes or increments to the base resources will work, and like how do you do it efficiently without waiting for a very long deploy?
That's a very great question, thanks. So yeah, we're going back to the beginning of the conversation. Regarding your first question about data scientists, that's the desired way. So they are not like thinking about deploying this kind of stuff. But in some setting, your MLOps team or MLE engineers might be a bottleneck in terms of the capacity that they have. Like, for example, they are not able to help data scientists, or they haven't built the CI/CD process so far. So like this one that goes from model to production. So that's why sometimes you end up writing a little bit of documentation which helps data scientists do this kind of process, like this kind of process, let's say, this one. Do this kind of process themselves. So sometimes this kind of thing works, right? Like when you allow your data scientists and machine learning scientists to commit to your GitOps repository. So, but that's not really a desired structure in my opinion. I'm saying that, again, this is how it should look like. Data scientist's job is very complicated. You should be fully dedicated to building your machine learning model. And you shouldn't be thinking about the rest of the stuff, because context switching for data scientists especially is, I mean, I've been working as a data scientist. I'm sharing my own experience. So yeah, if that answers the question that you asked first. What was the second one again?
Testing the YAML structures and
changes.
Yeah.
Yeah, thanks. So we are making use of 3 different repositories. And dev is something that we consider to be disposable in general. You can just break stuff. Dev is being broken, I don't know, once a week at least. So we're considering to be something disposable, where we want to change things both related to Kubernetes itself, like the cluster upgrade, let's say, and also the stuff that the community just shipped, like some new piece of software the community shipped, and we want to upgrade it. So we are first doing an upgrade in dev. And what we're doing is we are saying, for example, there are some applications that are crucial for the cluster, like the networking controller, let's say. We're making use of Istio. For example, Istio has just announced the new version, so we want to upgrade it. What we do first is we are doing the upgrade on dev. We have some crucial tests that we are running. The tests are mostly related to the inference services that we have in our platform. The inference service is the model that is being called live in your environment. So, and we have some tests that we are running. After we have the pull request merged, we have a CI/CD process that opens up the similar pull request button stage, where we are applying this pull requests and the tests are running without any manual contribution on it. We cannot contribute it manually, right? This pull request is opened up automatically. And then once those tests are succeeding, then pardon. Hope it's not me. So yeah, and then once it's done, the pull request to prod, and once we understand the staging is working properly, we're clicking a button, and then the pull request is being merged. So we have tests when there's upgrade. I'm good. So yeah, we have tests, but those are running when we are promoting changes between environments, and that's how we test stuff. We consider to be like the most crucial part of our platform to be the inference services that we are running. We are operating like around 25K RPS at the moment. So like requests per second to the models that we're running. So, and we are always checking if those models are working, if we're not introducing any downtime to these models when we are upgrading some crucial resource like Istio, let's say. Any other questions? Yeah.
Thank you very much. I was just wondering about data versioning. So if you get a new set of data coming in, calibration is now failing, how you handle that from the data input side?
What was that again, sorry?
For data versioning. So
Data versioning.
yeah, for when calibrating models.
Oh, nice. Thank you. So in terms of data versioning, we are currently in the process of building a feature store. So we haven't tackled this particular thing right now. Like currently is more of a mess, let's say. But I mean, like, here's my manager, he's laughing. So yeah, but we are in the process of building a feature store right now. And this problem is to be tackled. Thank you.
Got time for one more question?
Yeah, I was just really interested in your model of having the data scientist just focusing purely on modeling and working in the Jupyter notebooks, and then you taking care of the entire process of rolling that out to production. I'm just wondering how you make sure that production metrics like cost, like the actual deployability of the models, factors into the modeling process, so that you don't get to a point where data scientists produce these huge, costly models that work great in terms of the offline metrics, but then actually can't be used. Like, how does that factor in?
That's a good question. So yeah, starting from the fact that we are operating at a hybrid structure, and most of our servers for our platform are bare metal. Well, we do have some cloud servers as well, so we are not like, in terms of the bare metal infrastructure, we're forecasting the capacity that we might need for some models, but yeah, mostly it's not that costly as cloud gives. In terms of GPUs, for example, right? Like GPUs is the most important part of the cloud. So yeah, this is a little bit easier in our terms. But what we do before deploying the model, we launch a load test for sure, and we are trying to understand how many replicas of the service that's just being deployed by data scientists is going to be able to handle the load that is forecasted for this service, right? So, and in terms of, like, that's being done, we have a framework for it, that's being done for the for each model that's being developed by data scientists. And using this data, we're trying to forecast the load that we're going to have for the platform. If we understand that, for example, the model is that large, so we can handle I don't know, half of the RPS a second, and it needs to be handling 500. Then we have a dedicated, let's say, team of enthusiasts that likes to optimize stuff. So, and we are also sometimes just handling some model for optimization, so we're making sure it produces a bit more RPS than it is right now. So, and again, answering to your question, we are planning the capacity from the load tests, and we are trying to plan the RPS as well. For example, this year, this model is going to receive 100 RPS. Next year is going to be 300 or something. So yeah, and also we're not operating in a cloud structure, so it's a little bit easier for us, if that answers your question. Thank you.
Great. Let's thank Gleb again.